In this presentation, we will take a look at the present value of a single sum using months as the period as opposed to years as the period. This is going to be our information up top. We have the number of periods, which will be 5. This time, however, in terms of months rather than years as those 5 periods. We have the amount, 10,000. We have the rate, 12%. Few ways we can do these types of problems. One's with the formula, another's with the tables, another's with Excel. We're going to take a look at Excel and the tables here. You'll note the table to the right. We see the rate up top. We see the periods to the left-hand side. Neither of them showing what type of period. In other words, are we talking years? Are we talking month? What are we talking about? Well, as long as we use the same item for both the rate and the period, we should be good. We want to use months, and therefore the periods are what they are. They're going to be 3 months. We need to then change the rates to coincide with the months. That means we're going to take the 12% and divide it by 12 to get the monthly rate. And remember, whenever you see a rate, typically, unless it's stated otherwise, it means a yearly rate. That's the default that we talk about. And that's going to give us usually our rates that kind of look reasonable types of rates. If we talk about a monthly rate, we get very small rates. We start getting decimal rates and whatnot. So therefore, we typically default to a yearly rate. If we want to know the monthly rate, then we have to take that, divide it by 12. Also note that we don't see this too often in book problems, because if they're forcing us to use the tables, then they don't want us to have something that's going to be uneven, because then we can't use tables. So therefore, in practice, this happens more often. Excel, it doesn't matter if we have an uneven percentage, that's okay. So just note that in a book problem, that's why you don't see it as much, although it might be there in practice that we need to have periods that are going to be less than a year. So we'll take the 12 divided by 12, that gives us 1%. 1% being the percent, 3, or we're at 5 being the periods, and that's going to give us this 0.9515. So we'll have our 10,000 as the amount, multiplying that times 0.9515. That gives us the present value, 9515. Now we can also do this in Excel, of course. Excel, if we have our present value function, same present value function, only difference now being we'll take the rate, which is going to be in B4, that 12%, and then we will divide that by 12, the number of months in a year. And that's going to give us the 0.01 or 1%. Then in the number of periods, that's going to be B2, which is 5 periods. So that'll give us the 5. And then the payment amount is 0 because we're not talking about an annuity. We're present valuing a single sum. So the payment is 0, and then the future value, B3. So we're in B3. That's the future value, the 10,000. That'll give us our result here. It being shown in a negative. It's not even as well. That's okay. It's in a negative. Excel will then round it to whatever we decide to round it to. In this case, a whole number, 9515. Now we can also type that out, of course, within Excel in this format, equals negative. And I put a negative in front of the P in order to flip the sign, just to make it a positive resulting number. And that'll give us the rate. So the rate is B4 in B4. And then we'll divide that by 12, the number of periods, comma, the next function, number of periods, B2. So then within B2, 5 periods, comma, and then we'll have the payment, which is 0. There is no payment here. And then comma, and finally, we have in B3 is going to be the future value. So we want to take the future value, the one sum, which is the future value, as opposed to payments, which we would use in the annuity.